Hi, in this video we'll be finding the inverse DTFT. That means in my previous videos we have found x of e power j omega when x of n was given. That means discrete time signal was given and we were finding the DTFT of the same. Now given the DTFT we need to find x of n back. So from the basic of DTFT and inverse DTFT equations we can use that, but here it is given as a fraction, so I'll be solving it in partial fraction method. So let me at the very outset let me replace e power minus j omega as some variable t or any variable which you would like to prefer. So e power minus j omega is t, so I'll be substituting 6 minus 2 by 3 t minus 1 by 6, it is t square divided by minus 1 by 6 t square plus 1 by 6 t plus 1. That means I have replaced e power minus j omega by t. So if you have e power minus 2 j omega, it will be t square. Now simplifying this, I'll take minus out from both, so I'll be getting 1 by 6 t square plus 2 by 3 t minus 6 divided by 1 by 6 t square minus 1 by 6 t minus 1. That means I have taken minus out from here, from the numerator as well as denominator. Minus 1 divided by minus 1 will be plus 1. Now multiply by, taking the common denominator here, what do I get is 6 and 3. What is LCM? 6. So I'll be multiplying the numerator by 6 and denominator by 6 as well. So I'll be getting t square plus 3 twice, so 4t minus 36 divided by t square minus t minus 6. That means what did I do here? I multiply the numerator by 6 and denominator by 6. Previously I had taken minus out. Now in order to do the partial fraction expansion, the degree of the numerator must be less than degree of the denominator. So I need to divide the numerator t square plus 4t minus 36 by t square minus t minus 6. So t square, once a t square, because I need to get rid of t square, because the numerator has to be the degree of the numerator has to be less than the degree of the denominator. So the degree of the denominator is 2, the degree of the numerator has to be less than 2. So I get t square minus t minus 6. So if I subtract, I'll get 3t, I get 5t and minus 30. So that means a minus sign here, plus sign here and plus sign here. So t square gets cancelled. 4t plus 1t is 5t and minus 36 plus 6 is minus 30. So this can be rewritten as the quotient 1 plus remainder is 5t minus 30 divided by the denominator, that is t square minus t minus 6. So now you can see this is the converted form of this fraction. If you take the common denominator and simplify, you get back the same fraction again. Here the degree of the numerator is less than degree of the denominator, so we can go for partial fraction method. So it will be, if I take only this into consideration, it is 5t minus 30. So I will be writing here 1 plus 5t minus 30 divided by, if I factorize this, t square minus t minus 6, multiplication should fetch you minus 6 and addition should fetch you minus 1. So the roots are minus 3 and 2. So it should be t minus 3 into t plus 2. So the factors are minus 3 and 2 and t minus 3 and t plus 2. So it will be t minus 3 into t plus 2. Now what is the partial fraction here? If I consider this, it is a by t minus 3 plus b by t plus 2 is equal to 5t minus 30 divided by t minus 3 into t plus 2. So this one will remain as it is. I am just taking the second factor into consideration. So if I take the common denominator, a into t plus 2 plus b into t minus 3 is equal to the numerator 5t minus 30. Now how do I get a and b here? If I substitute t as minus 2, I will get 0 here. So t minus 2, see minus 2 plus 2 0, minus 2 minus 3 minus 5b is equal to minus 2. If I substitute here, it is minus 10 minus 30, so it is minus 40. So b will be 8. Now how do I find a? Substitute t as 3. If I substitute t as 3, I get 5a is equal to 15 minus 30 minus 15. So a will be minus 3. So the factors which I got, a is minus 3 and b is 8. So I will be getting 1 minus 3 by t minus 3 plus 8 by t plus 2. Now if I substitute back whatever I have substituted for t as, e power j omega was substituted as t, so it will be 3 divided by e power minus j omega minus 3 plus 8 divided by e power minus j omega plus 2. Now we have DTFT of alpha power n u of n as 1 by 1 minus alpha e power minus j omega. So I should be getting 1 by 1 minus. So in order to do that, I need to divide by 3, because I need to get 1 by 1 minus. So it is, if I divide numerator and denominator by 3, I get 1 by e power minus j omega by 3 minus 1. Here I need to divide by 2 to make this 1. So if I divide the numerator and denominator by 2, I will get 4 divided by 1 plus half e power minus j omega. Okay. Now 1 minus, if I take minus out from here, I will be getting plus. So 1 divided by 1 minus e power minus j omega by 3, and here I will be getting 4 divided by 1 minus half e power minus j omega. So this is x of e power. So taking IDFT x of n, what is inverse DTFT of 1? It is delta of n, which I have already proved. So here it is plus alpha power n u of n. What is alpha here? See, alpha power n u of n is 1 by 1 minus alpha e power. In place of alpha I have 1 by 3. So it is 1 by 3 power n u of n. Compare this with this. So here I have 4 into minus half power n u of n. So this is the time domain signal what I get for from the DTFT given here. So minus half because it has to be of the form 1 by 1 minus alpha e power minus j omega. So alpha becomes minus half here. So this is the final time domain equation got from frequency domain by taking IDFT. So in this problem, the DTFT is given to be cos omega plus j sin omega. Now from the basics of Euler theorem, we know that cos omega plus j sin omega can be written as e power j omega. So what is x of n from basics of inverse DTFT? It is 1 by 2 pi integral minus pi to pi into x of e power j omega e power j omega n d omega. So this will be 1 by 2 pi integral minus pi to pi. What is x of e power j omega? It is e power j omega into e power j omega n d omega. Remember, the integration is with respect to omega. So 1 by 2 pi integration minus pi to pi. So e power 1 plus n into j omega d omega, because j omega is constant. Now if I integrate this with respect to omega, so integration of e power j theta is e power j theta only, 1 plus n into j omega, and divided by the constant term other than omega, that is 1 plus n into j, from pi to minus pi. So it will be 1 by 2 pi into 1 plus n into j into, if I substitute the upper limit, it will be e power 1 plus n into j pi minus e power 1 plus n into minus j pi, because pi is minus there. Now if I rearrange this in the numerator, e power 1 plus n into j pi minus e power minus 1 plus n into pi j pi divided by, out of these 2 pi into 1 plus n into j, if I take 2j, what I'll be left out with is 1 by pi into 1 plus n, pi into 1 plus n. So e power j pi minus e power minus j pi divided by 2j is sine. So it will be sine theta. What is theta? Pi into n plus 1 divided by, I will be getting pi into n plus 1. So this is of the form sine pi theta divided by pi theta, which is nothing but sinc of theta. So this will be sinc of pi into n plus 1. So this is the inverse discrete Fourier transform of the function e power j omega, that is cos omega plus j sin omega. It is simple. So the third problem is x of e power j omega is equal to 3 minus 1 by 4 e power minus j omega minus 1 by 16 e power minus 2 j omega plus 1. Now what is the difference between this problem and the first problem which I have solved is the degree of the numerator is 1 and degree of the denominator is 2. So that means degree of the numerator is lesser than degree of the denominator. So we can directly go for partial fraction. Now as I have done in the first problem, I will substitute e power minus j omega as t. So I will be getting 3 minus 1 by 4 t divided by minus 1 by 16. Here I will be getting t square plus 1. So it will be like 3 minus 1 by 4 t divided by 1 minus 1 by 16 t square. So it is 3 minus 1 by 4 t divided by 1 square minus 1 by 4 t whole square. It is of the form a square minus b square. So I can write 3 minus 1 by 4 t divided by 1 plus 1 by 4 t into 1 minus 1 by 4 t. So this is the partial fraction I get. So it is a by 1 plus 1 by 4 t plus b by 1 minus 1 by 4 t is equal to 3 minus 1 by 4 t divided by 1 plus 1 by 4 t into 1 minus 1 by 4 t. So the equation I get is a into 1 minus 1 by 4 t plus b into 1 plus 1 by 4 t is equal to 3 minus 1 by 4 t. Now if I substitute t as 4 here, 4 gets cancelled, so I get 0. So t is equal to 4, a will be 0, it will be b into 4. If I substitute for t, 4 and 4 cancels, so I get 2, 1 plus 1, 2. So 3 minus 1 by 4 into 4, it is 1, 3 minus 2 is 3 minus 1 is 2, so b will be 1. Now how do I get the value of a? If I substitute t as minus 4, this will be minus 4 divided by 4, 4 gets cancelled, I get 1 minus 1, 0. If I substitute minus 4 here, it will be plus 1. So a into 2 is equal to 3 plus 1, that is 4. So a will be 2. So the value of a and b are 2 and 1 respectively. So what I will be getting there is a is 2 divided by 1 plus 1 by 4 t plus 1 divided by 1 minus 1 by 4 t. Now if I replace t by whatever I have substituted previously, it is 2 by 1 plus 1 by 4 e power minus j omega plus 1 divided by 1 minus 1 by 4 e power minus j omega. This is my x of e power j omega. Now from the standard quantity of alpha power n u of n, I mean the discrete time Fourier transform is 1 by 1 minus alpha e power minus j omega. So these are of the same form. So if I take inverse DTFT, the final answer would be 2 into minus 1 by 4 power n u of n plus 1 into 1 by 4 power n u of n. This is the final time domain equation. Why did I get minus 1 by 4 is the equation is of the form 1 by 1 minus alpha e power j omega minus j omega. So this is of the same form, so I can directly write 1 by 4, but there is a plus here, so it will be 1 minus 1 by 4, so it will be minus 1 by 4 there. Now in this problem, x of e power j omega is given in graphical form, which extends from minus pi to plus pi. So the total period is 2 pi. Now this DTFT would repeat itself at 3 pi. That means this whole pattern will repeat here as well as to the left. That means it is extending from minus infinity to plus infinity. Now if I want to get x of n from the basics of inverse DTFT, 1 by 2 pi minus pi to pi x of e power j omega n d omega. Now this is not continuous from minus pi to plus pi. So what I will be doing is I will be splitting this integral from minus pi to minus 9 pi by 10. What is x of e power j omega in that range? It is 2. This amplitude is 2. So 2, because this amplitude within this range is 2 into e power j omega n d omega plus minus 9 pi by 10 to minus 8 pi by 10 what is the value of x of e power j omega in that range? It is 1. 1 into e power j omega n d omega, plus we do not have any waveform here, so it starts from 8 pi by 10 to 9 pi by 10. So 8 pi by 10 to 9 pi by 10, what is the value? 1 e power j omega n d omega, plus integration 9 pi by 10 to pi, and the value is 2 e power j omega n d omega. So these are the 4 integrals which I will be getting if I integrate x of e power j omega from minus pi to plus pi. Now half of my work is done, so I need to integrate and just simplify. So it will be 1 by 2 pi 2 into e power j omega n. So it will be 2 into e power j omega n, integration with respect to omega. So jn is a constant, jn e power x is e power x divided by the constant e power j omega n divided by j omega n, from minus pi to minus 9 pi by 10, plus here I get e power j omega n divided by jn again from minus 8 pi by 10, from minus 9 pi by 10 to minus 8 pi by 10, plus e power j omega n divided by jn from 8 pi by 10 to 9 pi by 10, plus 2 into e power j omega n divided by jn from pi to 9 pi by 10. So this is what I get if I substitute if I integrate. So if I simplify it further, 1 by 2 pi into, now the limit has to be put for omega, so 2 by jn is a constant, 2 by jn is a constant. What I'd be getting is e power minus j 9 pi by 10 n, if I substitute the lower limit, minus e power minus j pi n. So this is for the first term. For the second term, again 1 by jn is a constant. If I substitute the limit, it is e power minus j 8 pi by 10 minus e power minus j 9 pi by 10 n. So this is for the second integral. For the third integral, the constant is 1 by jn again. So substitute the upper limit, e power j 9 pi by 10 n minus e power 8 pi by j 8 pi by 10 n. This is what I get, plus the last term, 2 by jn is a constant, 2 by jn into e power j pi n minus e power e power plus j 9 pi by 10 n, right? So if I simplify these, what I'd be getting is 1 by 2 pi is a constant which is present in the outside. So 2 by jn and 2 by jn, I have it here, so I can combine those. So I'll be getting 2 by jn into e power minus j 9 pi by 10 n minus e power minus j pi n plus e power j pi n minus e power j 9 pi by 10 n, because if I take 2 pi by jn constant, if I take 1 by jn constant, I'd be getting these two terms, e power minus j 8 pi by 10 minus e power minus j 9 pi by 10 n plus e power j 9 pi by 10 n minus e power j 8 pi by 10 n. Now if I simplify this further, 2 by jn, what I'd be getting here is e power j pi n minus e power minus j pi n I'll be getting, and if I take minus out, I'll be getting e power j 9 pi by 10 n minus e power minus j 9 pi by 10 n. So this is one term, the second term is this. Similarly here, 1 by jn into, I'll be getting e power j 9 pi by 10 n minus e power minus j 9 pi by 10 n. This is one term. If I take minus out, e power j 8 pi by 10 n minus e power minus j 8 pi by 10 n. I have combined these two terms and these two terms. So you have n here, 1 by 2 pi, I'll take it here. If you have j here, so multiply throughout by j, divide throughout by j. So 2 by n, j if I take, I need to have 2j here. So e power j pi n minus e power minus j pi n divided by j. In order to get 2j, I need to multiply here by 2 as well, and here I get e power j 9 pi by 10 n minus e power minus j 9 pi by 10 n divided by 2j. Again I've taken care of 2 by multiplying by 2 here. Here also I need to divide by 2, so I'll multiply here by 2. So I'll be getting e power j 9 pi by 10 n minus e power minus j 9 pi by 10 n divided by 2j, because j I'll take it inside, minus e power j 8 pi by 10 n minus e power minus j 8 pi by 10 n divided by 2j. So this would be 1 by 2 pi into 4 by n into, what is this? It is sine n pi. This is minus sine 9 pi by 10 n, because it is e power j theta minus e power minus j theta divided by 2j, and here I will get 2 by n into, this is sine 9 pi by 10 minus n minus sine 8 pi by 10 n. This is what I get. Now what is sine n pi? Sine n pi is 0, because sine pi is 0, sine 2 pi is 0, and so on. So what I would be getting here is 1 by 2 pi 4 by n, so minus 4 by n sine 9 pi by 10 n plus 2 by n sine 9 pi by 10 n minus 2 by n sine 8 pi by 10 n. So this would be 1 by n minus 2, so minus 2 1 by 2 pi minus 2 by n sine 9 pi n by 10 minus 2 by n sine 8 pi n by 10. So if I take I mean 2 outside, I'll be getting the simplified version of this. So 2 will get cancelled here. So or else I can write directly, this is my time domain equation of the original DTFT waveform. This is just using the mathematical simplification I have done. It looks complicated, but it is not if you are good with mathematics. Now the next problem, you have been given with x of e power j omega as cos square omega. Now cos square omega can be treated as cos square theta. So how can I write it in terms of the basic function of trigonometry? It is 1 plus cos 2 theta divided by 2. So here I can write 1 plus cos 2 omega divided by 2. So this can be written as half plus half cos 2 omega. So this can be written as half plus half. Cos 2 omega is e power j 2 omega plus e power minus j 2 omega divided by 2. So this can be written as half plus 1 by 4 e power j 2 omega plus 1 by 4 e power minus j 2 omega. Now, what is the DTFT of delta of n, which we have already proved? DTFT of delta of n is 1. Now, by using shifting property, if it is delta of n minus 1, then you get e power minus j omega into 1, because there is a shift. Delta of n minus 2 will be DTFT. It is e power minus j 2 omega into 1. So this is delta of n minus 2. What is delta of n plus 2? It is e power j 2 omega into 1, because the shift is positive. If there is negative shift, you get negative term. So the DTFT of delta of n plus 2 is this. So inverse DTFT of e power j 2 omega is this. So what is, so taking inverse DTFT, half is half into 1. So half into, what is the inverse DTFT of 1? It is delta of n plus 1 by 4. What is inverse DTFT of e power j 2 omega? It is delta of n plus 2 plus 1 by 4. What is the inverse DTFT of delta of e power minus j 2 omega? It is delta of n minus 2. So this is my inverse DTFT of cos square omega. It consists of impulse functions. Now in this problem, x of e power j omega is given to be a graphical waveform which is periodic with period 2 pi, because if it starts from here at 2 pi also, you get the same waveform back. So it is periodic with period 2 pi. Now how do I get the inverse DTFT? It is directly by using the basic equation minus pi to pi x of e power j omega n d omega. In all the transforms, we have only two equations. One is analysis and the other one is synthesis. So this is a synthesis equation in order to get the original signal back. Now if I split this integral from minus pi to pi, because x of e power j omega is having from minus pi to 0, it is having its value as e power omega, and from 0 to pi it is having value e power minus omega. So I'll split the integral minus pi to 0. What is x of e power j omega in that range? It is e power omega, e power j omega n d omega, plus 0 to pi, the value here is e power minus omega, e power j omega n d omega. So this would be 1 by 2 pi integral minus pi to 0 e power 1 plus jn into omega d omega plus integral 0 to pi e power minus 1 plus jn into omega d omega. Now if I integrate here, what is e power x? It is e power 1 plus jn into omega divided by the constant term 1 plus jn, because integration is with respect to omega, from minus pi to 0 plus e power minus together minus 1 plus jn into omega divided by minus 1 plus jn from 0 to pi. Now if I simplify this further, I would be getting 1 by 2 pi into 1 by 1 plus jn. I will write it as jn plus 1, because here I have jn minus 1, jn plus 1. And if I substitute the limit, if I substitute the upper limit as pi, omega is equal to 0, I will get e power 0, that is 1, minus, if I substitute omega as minus pi, I will be getting e power 1 plus jn into minus pi. So I will be getting minus sign here. So this is the term which I will be getting. Now the second term is plus 1 by jn minus 1. It is jn minus 1 is a constant again. So if I substitute the upper limit, it is e power minus 1 plus jn into pi plus minus e power 0 you get. So it will be e power 0 is 1, and this is the outer limit. I had to clear this in since I didn't have enough space there. I will be continuing here. So it is 1 by 2 pi into 1 by jn plus 1 into 1 minus, I can split this into e power minus pi into e power minus jn pi plus 1 by jn minus 1 into e power minus pi into e power jn pi, and there is a minus 1. So this is the entire thing which I will be getting. Now if I simplify this further, it will be 1 minus, what is e power jn pi? E power minus jn pi is cos n pi minus j sin n pi. Sin n pi is again 0, because any multiple of pi with sin is 0. Cos n pi is minus 1 power n, because cos, if you put the values for n, you will get plus 1 minus 1 plus 1 minus 1 alternatively. So that is why you get cos n pi as minus 1 power n. So what I will be getting here is 1 minus e power minus pi into minus 1 power n divided by jn plus 1 plus 1 by jn minus 1 into e power minus pi. Again you have e power jn pi, it is cos n pi plus j sin n pi. Again sin n pi is 0, so cos n pi is minus 1 power n and minus 1. So this is what I get. Now if I take the common denominator, it is a plus b into a minus b. So it is a square minus b square, jn square minus 1. And if I simplify here, I will be getting jn minus 1, jn minus 1 minus jn e power minus pi into minus 1 power n plus e power minus pi into minus 1 power n. Many more terms to go, and here plus jn e power minus pi minus 1 power n minus jn plus e power minus pi minus 1 power n minus 1. So this jn gets cancelled with this jn here. Minus 1 it is minus 2. So 1 by 2 pi. Jn square is what? It is j square n square. J square is minus 1. So I'll be getting minus n square minus 1. And here I'll be getting minus 1, it is minus 2. Then these two terms get cancelled because jn e power minus pi minus 1 power n plus and minus, and I will be getting here minus 2 plus 2 e power minus pi minus 1 power n. So 2, if I take it out, that will get cancelled with this 2. So I will be getting 1 by pi into e power minus pi minus 1 power n minus 1 divided by minus n square minus 1. So this is my inverse DTFT of the signal which was shown earlier. So I have solved different types of problems under inverse DTFT. I hope this will be useful. Thank you for watching.